Good morning to all. I am PM Chellapandi, Assistant Professor. I have been working as an Assistant Professor in SNS College of Technology, Coimbatore. Today, I am going to present you a case study in the topic of sampling theorem. Let's go. What is inside of this video? First, what is sampling? Sampling is nothing but it is the process of taking the samples of the signal at intervals. In our signal, we will take a particular intervals as a sample, that is called sampling. Next, what do you mean by aliasing? We cannot distinguish between higher and lower frequency, that is called aliasing. What is saying the sampling theorem? It is saying to avoid aliasing, sampling rate must be at least twice the maximum frequency component of the signal. Sampling theorem says there is enough information to reconstruct the signal, which means sampled signal looks like original one. Why? Most signals are analog in nature and have to sample. Loss of information, that is, for example, you take a touch phone, for example, touch tone system of telephone dialing. When button is pushed to sinusoid signal or generated. I repeat, touch tone system of telephone dialing. When button is pushed to sinusoidal signal or generated, that is called tones, and transmitted. A digital system determines the frequency and uniquely identifies the button system digital. Here through this picture you can get a more clarification. Now, where in communication, here I am just going to convert analog signals into the digital information. Sampling and involves analog to digital conversion. Okay, right? Here analog signal is giving input to sample. Sampling signal will give as digital signal that will be converted to DSP. Then again we will get digital signals. Okay. Now convert the digital information after being processed back to analog signals involves digital to analog conversion and reconstruction. For example, text to speech signal characteristics are used to generate artificial sound. Here perform both A and D or D divided by A conversion. For example, digital recording and playback of music, signal is sensed by microphones, amplified, converted to digital processed, and converted to back to analog to be played. Sampling rate. Here you can see a sine wave. Here I'm going to take 5 times sine into 2 pi 4t. Then the amplitude is equal to 5, frequency is equal to 4 Hz. We take an ideal sine wave to discuss effects of sampling. A sine wave signal and correct sampling. Here you can see a signal in seconds. Here 5 times sine 2 pi 4t. Then amplitude is equal to 5, frequency is equal to 4 Hz. Sampling rate is equal to 256 samples per second. Sampling duration is equal to 1 second. We do sampling of 4 Hz with 256 Hz, so sampling is much higher rate than the base frequency. Good. Thus, after sampling, we can reconstruct the original signal. And undersampled sign. Here sampling rate is 8.5 Hz and the frequency is 8 Hz. Okay. Now you can look at here loss of information. It's given here. The red dots represent the sampled data, and undersampling can be confusing. Here it is suggest a different frequency of sampled signal, right? Okay. Now the summary of this case study is: Fourier analysis of periodic function focuses on the study of Fourier series. The Fourier transform is a way of transforming the continuous signal into a frequency domain. The discrete time Fourier transform is a Fourier transform of a sampled signal. The discrete Fourier transform is a discrete numerical equivalent using sums instead of integrals that can be computed on a digital computer. As uh, one of the application of DFD and then inverse DFD can be used to compute standard convolution product, and thus it is to perform linear filtering. Thank you so much. I hope you can get a new idea on this case study. Thank you.